Hello again, friends, and welcome to today's lesson 3.3, Number Lines and Equivalence. So, as we discussed yesterday, there's that word again, equivalence. Remember, equivalence is a fancy word for equal. So, when we are comparing fractions or the parts of wholes, we want to find fractions that are equal to each other. So yesterday we learned that we can use a tool, fraction circles, in order to find equivalence between more than one fraction. Today we're going to use another tool to also work on finding equivalence. So today you're going to want to go to the very back of your math journal and you're going to want to find activity sheets 1 through 6. Activity sheets 1 through 6 are just like the fraction circles that we needed for our last lesson. They're way back in the appendix of your math journal, and they are sheets that are almost like a cardboard type material. If you don't have your paperback math journal, of course, you can always go to the Everyday Math Connect Ed website. You have access to that. You can click on today's lesson 3.3, and you will be able to find those pages in a digital format. You can also go onto our Google Classroom and find them as a printable. So you can use any one of those tools to access the number lines. Those are pictures of fraction circles that also have a number line equivalent. So they'll be very helpful to you for today's lesson. So yesterday we were talking about fractions, which we know a fraction means a part of a whole. And we also know that fractions are set up in a specific way with a number on top that we call the numerator, and that is represented by the number of shaded parts. And the denominator is on the bottom, and the denominator represents the total number of parts possible to be shaded. So yesterday we were talking about different ways to find equivalence using these fraction circles. We can find out that even if we split one whole into any number of different denominators, the numerator will also change because we're trying to find equivalence. So today we're going to continue that work using a different tool. We're going to use a number line. So if we wanted to find out how many parts of a number line we would need to shade or fill in order to find the fraction, we can use this tool. So if we were finding fraction circles, we can cut a Thanksgiving pumpkin pie into different size pieces, just like we did yesterday with the fraction circles. And we know that the number of pieces that we have is the denominator possible. And if we were to shade all of them in, we would have shaded one whole. So if I were to represent that on a number line, you would see a tool like this with 0 at one end and one whole at the other end. And all this space in between represents however many pieces there are to make this whole. If I'm using the example of 1/3, I know that I need to fit thirds into this one whole. I need to break this one whole entire bar into 3 equal pieces. So I would use my ruler or whatever tool I have available to me and do my very best at showing equal parts. And I would split this into 3 equal chunks like this: 1 part, 2 parts, and 3 parts. Just like we did with the numerator and the denominator in the fraction circle example above, we can also do the same work identifying the fractions on a number line. This would be equivalent to 0 parts out of 3 parts possible, or we can represent it with the whole number 0. This first spot that we come to on our number line represents 1 part, this first part, out of 3 parts possible. So we would write the shaded number or the dotted spot on our number line, 1 out of 3 parts possible. So this spot on our number line would be identified as 1/3. The next spot over would be the second chunk, 1 part, 2 parts out of 3 parts possible. We would call that 2/3. as soon as I get to 1 whole, you'll remember back from a few lessons ago that anytime you have 1 whole, we know that that means that all 3 parts out of 3 parts possible have been shaded. So when you see a number 1, that's the whole. That means that all the parts out of all the parts possible have been shaded. The numerator and the denominator should both be the same in order to equal 1 whole. Let's try another example. If I wanted to break my number line into 8 parts, I would have to identify this as 1 whole. And I know that that means that the numerator and the denominator are going to be the same, which means this will be 8 eighths. On the other end of my number line, just like on a ruler, I would start with 0. And if I'm talking about fractions, that means 0 parts are shaded out of 8 parts possible. You could say 0 eighths, or you could just say 0. Most people just say 0. So just like I would on a ruler, I would identify each point on my number line. So I would find halfway in between. That's 4, 3, 2, 1, 5, 6, 7. Now my parts don't look exactly equal. I'm not an artist, but you get my point. So if I know that I'm breaking this number line into 8 equal parts, I know that the denominator for each one of these spots on my number line needs to be an 8, because we're finding how many parts out of 8 we have covered. So if I want to find 4 eighths of my number line, I'm going to shade in 1 eighth, 2 eighths, 3 eighths, 4 eighths. So if I shade all of those eighths in, 4 eighths is my fraction that I have covered. So that means that 1 eighth, 2 eighths, and 3 eighths are also all included. And you can continue on to see what the rest of our our numerator figures would be. Now, once you know how to properly label a number line, then you can also find equivalent fractions. So just like we did yesterday when we were using fraction circles and we were laying the light green colors on top of the red ones, and we were laying the dark purple colors over the green colors to find out equivalent fractions, you can also find equivalence using things like this. So for example, I know that if I look at this number line, I can see that I have colored in 4 pieces out of 8 possible. But what if I wanted to name 4 eighths something else? What if I wanted to have an equivalent fraction or another name? Same value, just a different name. So it's kind of like you with a full name, and then some of you may have a nickname. You still are the same person, you just have a different way of referring to yourself. Equivalent fractions are kind of like that. So if I look at this, I can also see, what if I broke this number line, same exact number line, what if I decided to break it just into 2 parts? What if I called this 0 out of 2, and 1 whole over here was representative of 2 parts out of 2 possible? If that's the case, then this marks the middle part. 1 part out of 2 would be right here. And this is 2 parts out of 2, 1 whole. So if I look at these 2 number lines right next to each other, I can start to see equivalence right away. I can see that 4 halves is at the exact same spot on this number line as it is on this number line, but it's labeled as 1/2. That shows me some equivalence. That tells me that 4 eighths is equal to 1/2. It also shows me that when I mark 2 eighths on my number line, if I were to break this number line into 4 parts possible, then this would be 0 out of 4 parts, 1 out of 4 parts, 2 out of 4 parts, 3 out of 4 parts, 4 out of 4 parts, and look what we just found. We found that 1/2 is equivalent to 2/4. We found that 2/4 is equivalent to 4/8. We found that 1/4 is equivalent to 2/8. Wow. We're finding so much equivalence just by using that number line tool. So today I'm going to encourage you to find activity sheets 1 through 6 in the back of your journal page. You can also find them on the Google Classroom, or you can also find them on the Everyday Math website, and definitely cut those out and use them to help you in your work today. So as you go off, you're going to be working on journal page 73, but be sure to look on Google Classroom because you're not going to do all the problems. You're only going to do a few of them. Number 2, number 4, number 5, number 6, number 7. You'll do all of the journal page on 75, but there are no math boxes today. So after you finish your journal work and you've checked it to see how you're doing, make sure you go back and do the exit ticket to let Miss Jungle know how your confidence is feeling and how you're doing on the comprehension of this concept so that I know who to meet with. As always, fourth graders, if you have any questions or if you want to do some examples together with Miss Jungle, you can feel free to hit me up in the chat or send me a message that lets me know that you want to do some examples together. Otherwise, you're going to go off and do journal pages for 3.3, number 73, and page 75. No math boxes today. Don't forget your exit ticket. Off you go, fourth graders.